Hello, everybody. I'm going to take a little bit here to go over a short tutorial lesson on how to do circuit puzzles 1, 2, 3, 4, and 5 from circuit sheet number 1. Some of these we've already done in class together, but for those of you who have missed those class opportunities, this is again just an opportunity to kind of get caught up. What we need to do is we need to use these circuit puzzles to demonstrate our understanding of how to analyze electric circuits. Electric circuits can be analyzed qualitatively by understanding how current and voltage act in a series and parallel connection. Also, you can use and analyze electric circuits quantitatively using an Ohm's law formula. Voltage, right, is current times resistance. Current is voltage divided by resistance. Resistance is voltage divided by current. Lastly, we can do a power calculation, known as Joule's law, to demonstrate an understanding of, well, really just a kind of a peace of mind to know that we're doing this correctly. Okay, so what we'll do is we'll, at the very end, we'll calculate current times voltage to get power for not only the total circuit but also each resistor. Okay, and I'll lead you through the processes involved. Okay, so what I would suggest is turn on your tools, your comments. That way you can annotate the circuit along with me as I do. So one of the things that we should know is that the total current comes from the positive side of the battery. So if we were to annotate this battery, the positive side of the battery is the long end, the short end is the negative side. And the current would come, we follow the current from the positive side of the battery all the way around to the negative side. So the current would look like this: down, over, up, over, back down again. This is what's called a series circuit. Okay, now we're going to take some notes over here on the side so we can keep this straight. A series circuit, series resistors are on the same pathway. That's the key indicator right there. All three of these resistors were on the same pathway. I know that pathway looped around, but it's still one pathway of charge. That makes these three resistors in series with each other. It also makes these three resistors in series with the battery too, because all of it is one loop, one pathway. Parallel resistors, parallel means separate pathways. Sometimes you have one resistor on a separate pathway. Sometimes you have multiple resistors on a separate pathway. But parallel does not mean geometric parallel where two lines do not intersect. Parallel in physics terms and electric circuit terms means the current has split up into separate pathways. So we need to know what these terms mean in order to analyze the chart. Okay, and how current and voltage behave. So current in a series circuit is the same. Current in a parallel circuit gets added together. Current in equals current out of a parallel circuit. Voltage in series gets added together, summed, and voltage in parallel is the same. These two I would put a lot of focus and attention on. They will help you as you analyze. Okay. So with that said, I want to remind you our very first step in doing any circuit analysis problem is to trace the current through the circuit. Okay. Trace the current through the circuit like I did with the marker pen. Okay. All the way around. And that's important because that's going to tell you what kind of circuit it is. This, number one, is a series circuit. Oops. Number one. Number two, if we were to do that first step, we can see the current goes this way, and now it's going to split. And you can see, since the current splits into two separate pathways, these two resistors are in parallel with each other. And the two currents add up together to the total current coming back to the battery again. Number three, exactly the same thing. The only difference is the current splits three ways instead of two ways. Number 4 and 5 have the same circuit, but different information given. So if you look at how the circuit, how the current moves in this circuit, we have the current going down, over, and then up across the middle, over across the outside. the current across the two pathways add up together to the total current coming back to the battery again. In a way, it's very similar to number 2, two parallel pathways. The difference is resistor 1 and resistor 2 are two resistors on the same pathway, meaning they're going to be in series. So that means their voltages will be summed and their current will be the same. Okay, so that's what we have to learn how to do, is we have to learn how to see these different pathways of electric charge in terms of how it all operates. I'll do all these. There we go. Okay, so with that said, we're going to go ahead and get started. And feel free to pause the video at any one point in time, rewind if you need to, but this is meant to be a tutorial to kind of help get you caught up, okay? Now, we are given some information to start with. We're given that there's a 2 ohm resistor, a 4 ohm resistor, 6 and 8 ohm resistor around the circuit. The 4 ohm resistor, the resistor 1, has 2 amps of current going through it, and that's all we know. The very first thing I would do to start any puzzle, if I am given 2 pieces of information, okay, voltage, current, and resistance, if I'm given any of these 2, calculate for the third, okay? It's easy math, guys, it's easy math. Voltage is current times resistance, so 2 amps times 4 ohms is 8 volts, okay? We got that, and annotate as you go. That's 8 volts. But now I don't have any other Ohm's law calculations I can do, so I need to go to my series parallel chart and use my qualitative concepts. Well, what do I know? I know that this is a series circuit, and I know series circuits have same current and summed voltage. Well, let's start with current. Since I know the current is 2 amps across this, and they're in series together, that means the current across R2 is 2 amps, the current across R3 is 2 amps, and the current across for the battery, the total coming from the battery was also 2 amps. That allows me to fill out quite a bit right off the bat. Okay, now notice we have 2 of the 3 variables here, so we can calculate the voltage for resistor 2 and resistor 3. 2 amps times 6 ohms is 12 volts. 2 amps times 8 is 16 ohms. Okay, now what we have is we have voltage in series gets summed and added together. So 8 plus 12 plus 16 is 36 total volts. And if we use our Ohm's law calculation here for resistance, voltage over current, 36 divided by 2 is 18 total ohms of resistance for the entire circuit. So all the information on the top row is for the whole circuit as a whole. Total voltage, total current, total resistance. All the other values are individual values for each resistor. Okay, so one of the things that I want to do before we do our power calculations, I want to show you how all this works. Again, reiterate one point. When you have the total voltage on the battery, in this case we do, 36, you need to remember to break down the battery into 2 parts. The positive side, which is 36 volts. There we go, sorry. 36 volts on the positive side, 0 volts on the negative side, okay? And as we go across resistor 3 was 16 volts. Oopsie. Resistor 3 was 16 volts, resistor 2 was 12 volts, and resistor 1 was 8 volts. So notice this point of the circuit right here, that point of the resistor, is connected to a region of high potential. That means that this point right here also has a potential of 36 volts because it's connected to the positive side of the battery. However, as we go across resistor 3, we drop 16 volts of potential. There is a voltage difference of minus 16 volts. Every time you go across a resistor, we reduce voltage. So we are now down to 20 volts, okay, when we subtract. Now, the 20 volts here, that's connected to this side of the resistor. That means there's 20 volts here as well. But notice we subtract 12 volts across this resistor. So now you can see in this section, we are now down to 8 volts. 20 minus 12 is 8. Okay, and then going into this final resistor, we are subtracting 8 volts from 8 volts, and we get 0. So the sum total of the voltages add up to 0. Or another way you could look at it is the individual voltages across each resistor added up to the original battery voltage. Okay, so there's several ways you can look at it, but what does it really summarize? series voltage is summed. Okay, so let's go ahead and do our power calculations. The total power of the circuit is 72 watts. Okay, how do we get that? 36 times 2, we're going current times voltage. Resistor 1 power is 16 watts. Resistor 2 power is 24 watts. And resistor 3 power is 32 watts. Now, the final check is to make sure that these individual powers add up to the total power. So 16 plus 24 plus 32, indeed, these do add up to 72 watts. All right, number 2. Well, in number 2, we are given the battery voltage. So the very first thing I would do, and notice you're not given anything to do an Ohm's law calculation. To do an Ohm's law calculation, you have to have 2 of the 3 variables. I only have 1 of the 3 variables in each case. So I have to jump right on the series parallel rules. Well, if you remember when we ran the circuit, the current through the circuit here, the current split up 2 times. That makes this a parallel circuit. What do we know about parallel circuits? Parallel resistors have summed current, the currents add together, and they have same voltage. So how would that look? Well, the battery voltage itself can be split into 12 volts on the positive, longer side, and 0 volts on the negative side. Now, every corner of the bottom part of the circuit is connected to a region of high potential, 12 volts. So I'm going to type that in down here, 12 volts, 12 volts, 12 volts. Every corner on the top part of the circuit is connected to a region of low potential, or the negative side of the battery. So I'm going to type in 0 volts, 0 volts, 0 volts. The potential difference would be subtracting the 2. The potential difference across the battery is 12 minus 0, or 12 volts. The potential difference across resistor 1 would be 12 minus 0, or 12 volts. The potential difference across the second pathway, also 12 minus 0, or 12 volts. So we can fill out some information about voltage being the same in parallel. Now that opened up a couple Ohm's law calculations here. 12 volts divided by 2 ohms is 6 amps. 12 volts divided by 4 ohms is 3 amps. Now that I have the current across these pathways, I'll fill them out. Now I look at the other part of this, okay? Parallel pathways have same voltage, we already did that, but they have summed current. So 6 amps across one pathway plus 3 amps across the other pathway has to add up to 9 total amps of current. Do an Ohm's law calculation to figure out the total resistance. And we have 12 over 9 is 1 1/3 ohms. Do your Ohm's law, do your Joule's law calculations for power. 12 times 9, what is that, 108? Yeah, so 108 watts of total power for the circuit. Resistor 1 is dissipating 72 watts of power. Resistor 3 is dissipating 36 watts of power. And if you add those, 72 plus 36, they do add up to 108. We know we did circuit puzzle number 2 correctly. Okay, number 3. Also a parallel circuit. Things are split 3 ways, so I'm going to be looking at the parallel side of things. Parallel current is summed, parallel voltage is the same. Notice we can do an Ohm's law calculation here. I have 3 amps times 12 ohms, 36 volts. Okay, so I can fill that out right off the bat. Then I'm stuck with I can't do any more calculations, but what I can do is I can go to my parallel side of the chart and look at this right here. Current in parallel is summed. So 2 amps plus 3 amps plus 1 amp is 6 total amps of current. Okay. Now the other thing I know is that voltage in parallel is the same. Well, what does that mean? Well, I've got 36 volts across this pathway here. What that really means is 0 volts on the negative side. Remember, the whole top part up here, all of this area up here is connected to the negative side of the battery, which is 0 volts. Everything on the bottom is connected to the positive side of the battery. Well, the potential difference across this pathway is 36 volts. We get that by going 36 volts minus 0. But voltage in parallel is the same. So that means that this should also be 36 volts. This should also be 36 volts. and the battery total should be 36 volts. When we do that, that allows us to fill out quite a bit. Okay, now let's do some Ohm's law calculations to fill in the resistor values. The resistor 3 is 36 volts divided by 1 amp, or 36 ohms. Resistor 1 is 36 volts divided by 2 amps, or 18 ohms. And the total battery resistance is 36 volts divided by 6 amps, or 6 ohms. Okay, go to your power calculations. 36 times 6 is 216 watts. Resistor 2 is 36 times 2, or 72 watts. Resistor 3 is 36 times 3 is 108 watts. And then lastly, 36 times 1 amp, or 36 watts. Make sure you add these together. 72 plus 108 plus 36 does add up to 216. We did indeed do puzzle number 3 correctly. On to number 4. Number 4 has 12 volts across the battery. So, and notice I do have an Ohm's law calculation I can do for total resistance. 12 volts divided by 2 amps is 6 total ohms of resistance. Okay, but other than that, here's what I know. I know that the current goes down here, splits up. I know that resistor 1 and 2, make a note of this, R1 and R2 are in series. Okay, why is that? Because they're on the same pathway, but they're in parallel. Both of them are in parallel with R3 because R3 is on a separate pathway. So you're going to be looking at both sides of the chart here. Okay, first thing I might do is I might take that battery voltage and split it up a bit. 12 volts on the positive side, 0 on the negative side. That would be 0, 0, and 0. Down here it would be 12 volts, 12 volts, and 12 volts. Okay, so what that tells us is 12 volts minus 0 is 12 volts of potential difference across the battery. I also know that 12 volts minus 0 is going to be 12 volts for the whole pathway here. Now be careful. Do not assume that this is going to be 6 and 6. I know those add up to 12, but the resistances aren't the same. Current follows the path of least resistance. Okay, so the one with the least resistance is going to get the, well, they're going to get the same current because it's the same pathway, but the one, if we look at our Ohm's law calculation here, if the current's the same, the one with the greater resistance is going to get the greatest potential drop across it. Okay, so look at R1. R1 is a higher resistor. More of the voltage is going to be here across R1 than R2. But here's what I do know. R3 has a potential difference of 12 minus 0, or 12 volts, and it's on its own pathway. So that is where you can begin. 12 volts across R3. Again, these have to add up to 12, but I don't know what that is going to look like yet, so I'm going to hold off on that. But here's what I do know. Something just opened up here. 12 volts divided by 15 ohms is 0.8 amps of current. So here's what I know. Across this pathway, we have some unknown current. We don't know what it is. We know there's 2 total amps of current that go into the split. We know that there is 0.8 amps of current coming out of the split. 0.8 amps. So 0.8 amps plus what has to add up to 2? Well, that's going to be 1.2 amps. Okay, and why am I writing 1.2 amps for both resistors? Because they are in series. Current in series is the same. So 1.2 amps, 1.2 amps. Erase this annotation here. Okay, now we can do the calculations. 1.2 times 6 would be 7.2 volts. 1.2 times 4 would be 4.8 volts. And indeed, these two voltages do add up to 12. Do your power calculations. 12 volts times 2 amps is 24 watts. Now this is getting a little bit weird. So 7.2 times 1.2 is 8.64 watts. 4.8 times 1.2 is 5.76 watts. And 12 times 0.8 is 9.6 watts. So make sure you add these up. 8.64 plus 5.76 plus 9.6. And indeed, all three of these add up to 24 watts. We know we did circuit puzzle number 4 correctly. Well, just like we saw about resistor 1, resistor 2 being in series with number 4, same thing here. Resistor 1, resistor 2 are in series again because we know the current's going to go down and it's going to split across these two pathways. Okay, we know 24 volts across the battery, so we can actually split the circuit in half. 24 volts on the positive side of the circuit, 0 volts on the negative side. So 0, 0, 0, 24, 24, 24. Okay, so I see easily a bunch of ways we could get this circuit puzzle started. Okay, I see 1, 2, 3 possible ways we can get this thing going. Okay, 4 actually. All right, so first thing I look at is any Ohm's law calculations. I don't see 2 out of 3 variables, so we're stuck going right to our series and parallel rules. Well, see if you can start with the series part inside here. Okay, remember, series resistors have same current and some voltage. Well, there you go. Since R2 has 4 amps going across it, R1 must also have 4 amps going across it. So we have 4 amps of current there. Now, the other thing I see is that the voltage needs to add up to something. So if the total potential difference across the battery is 24 minus 0 or 24, the potential difference across this whole pathway here is 24 minus 0 or 24. But 8 volts of it is already here on R1. That means R2 has to be 16 volts. Because again, voltage in series is summed. 8 plus 16 is 24 across the whole pathway. And resistor 3, well, 24 minus 0 or 24 volts just for resistor 3. So we filled out a lot right off the bat here. Let's do some Ohm's law calculations here for resistors 1, 2, and 3. 8 volts divided by 4 amps is a 2 ohm resistor. 4 volts divided by 4 amps is a 4 ohm resistor. And 12 volts divided by 2 amps is 24 volts divided by 2 amps is a 12 ohm resistor. Total current. Well, the current across this pathway, 4 amps, plus the current across this pathway, 2 amps, has to add up to the total of 6 amps. Not 10 amps. You're not going 4 plus 4 plus 2. You are treating this as one 4 amp current plus this 2 amp current right here. Okay, Ohm's law calculation will help us fill out the last box here for resistance, and 24 volts divided by 6 amps is a 4 ohms of total resistance for the circuit. Okay, filling out your power, 24 times 6 would be 144 watts of power. Number 1 would be 32 watts of power. Number 2, resistor 2, would be 64 watts of power, and the last one would be 48 watts of power. So add them up, 32 plus 64 plus 48. Indeed, all three of these do add up to 144 watts, which is the total power in the circuit. Okay, I hope that you found that helpful. If you have any further questions, please contact me so that I can get that straightened out for you.